Within this lesson, we'll look at multiplying and dividing by 10, 100, and 1000. Here we have 8 times 10, 8 times 100, and 8 times 1000. We're taking that same number 8 and multiplying it by 10, 100, or 1000. 8 times 10, we have 8 tens, which we also write as 80. 8 times 100, we have 8 hundreds, which we write as 800. And 8 times 1000, we have 8 thousands, which we can write as 800, 8 followed by 3 zeros. Notice the pattern that we have here, where it is when we're multiplying by 10, and a whole number by 10, we're just adding 1 0. Whole number by 100, we have 2 zeros as placeholders so that the 8 can be in the hundreds place, and similarly for the thousands. In much the same way, we can take that number 8 and divide it by 10, divide it by 100, or divide it by 1000, so that that digit, 8, ends up being placed in a different place. And then so we have 8 divided by 10. That digit ends up getting placed into the tens place. Remember, when we divide by 10, we actually shift that digit one place over to the right, because that digit is going to be worth 1/10 as much. So 1 divided by 10 is 1/10, so we have 8 tenths there. Similarly, 8 divided by 100, I can also write as 8 over 100, and we read that as 8 hundredths, which we can write as a decimal as 0.08. Remember, when we're dividing by 100, we shift that place over twice. Do you notice the pattern here? What will we get when we get 8 divided by 1000? 8 thousandths, which is written like that there. Let's look at 2 more problems where it is that we are looking at 7 and 6/10 and multiplying that by 10. And we'll also take that same number and divide it by 10. 7 and 6/10 times 10. Now, if we just had 7 times 10, what would that be? That's right, we shift that 7 over one spot. That 7 times 10 would be worth 70. And that 6/10 times 10 also gets moved over one place, because 1/10 times 10 is already 1. So 6 of those tenths, we have 6. So we have the number 7, 6. That decimal point comes straight down. For when we write it, we do not include that decimal point. Now, would the number 7 and 6/10, or 7.6, get larger or smaller if we divide by 10? The value of it would be smaller. 7 ones, actually divided by 10, is 7 over 10, which is 7/10, bringing that decimal point straight down. And then those digits following also get shifted over one place value over to the to the right, because they are now worth less. So we have that number 0.76. We rewrite that as 0.76. So 7.6, or 7 and 6/10 divided by 10, is equal to 76 hundredths. It's your turn. You try these. Think about whether the number is going to be bigger or smaller, and how many place values that you would move those digits if you're multiplying by 10, dividing by 10, or multiplying by 100. Pause the video. For the first one here, 5.8 times 10 would get 58, because each of those digits would end up being worth more. 65 divided by 10. 110 divided by 10 is 1. That way 6 tens, or 60 divided by 10, is 6. That's why that goes there. We got the 5 right here. And the decimal point comes straight down. So we have 6.5, or 6 and 5/10. 9 hundredths is written as 900. How'd you do? We'll keep working on it. Here I'm showing when we're multiplying by 1,000, we have 0.97 times 1,000, or 97 hundredths times 1,000. You know, we know that 1 times 1,000 is 1,000, so our answer should be very close to 1,000. Let's take a look. Multiplying by 1,000 is like multiplying by 10 still. We'd only have one place. By 10 again, that would be times 100, which is 2 places. And times 10 again would be 1,000. That is, 10 times 10 times 10 is equal to 1,000. So we'll actually move each of these places and make them one bigger each time. 3 times, though. So that tenths, not only to the ones, not to the tens, but all the way to the hundreds. And the 7 follows to the tens place, and we need a placeholder in the ones place. So that 0.97 times 1,000 is 970. Very close to that 1,000 that I was stating earlier of 1 times 1,000 equaling 1,000. Here we have 52 3/10 divided by 1,000. Which case is our number getting bigger or smaller? That is correct, it gets smaller. It's getting smaller by 1,000th. In other words, our number's going to get pretty small here. Each digit ends up getting shifted over to the right then, not once, not twice, but 3 places. So we're not even in the tens place, we're all the way in the hundredths place with that there. In other words, 50 divided by 1,000 is equal to 5 hundredths. Just like if we take that 1, well, in this case it's 2, but if we did take 1 divided by 1,000, it'd be worth 1,000. So that's why 2 divided by 1,000 is worth 2 thousandths. And that's why it gets shifted over 3 places. And similarly, that 3 in that number ends up getting placed there. We have 0.0523 as our answer there, or 523 ten-thousandths. Here are 2 problems for you to try. Pause the video and work them out. For that first one there, 78 divided by 1,000. Look how I can rewrite this. 78 over 1,000, or 78 thousandths, which we write as 0.078. Each of those places got shifted over not once, not twice, but 3 places. So I had to have that 0 there as a placeholder when I was working out my answer. 619 thousandths times 1,000 is equal to 619, where each of those ends up getting shifted over to be made larger. 6/10 times 1,000 is equal to 600. 100 times 1,000 is equal to 10. And 9 thousandths times 1,000 would equal 9 for our 619. Remember, when you are multiplying by 10, 100, or 1,000, each of those places and each of those digits in those place values ends up getting larger. In the case of multiplying by 10, we actually move each of those digits 1 space, or 2 spaces, or 3 place value spaces, which ends up making them larger. And when we divide by 10, or divide by 1,000, we actually shift those place values over to the right, either 1 digit, 2 digits, or 3 digits, depending on what it is that we are dividing by. Again, to the left, if you're multiplying by 10, 100, or 1,000, and to the right, if you're dividing by 10, 100, or 1,000.